Sure. Well, thank you so much for having me. It's a pleasure to be back. Well, to kick off, I want to introduce myself personally. So as mentioned, my name is Max. My background is in mechanical engineering and in Germany. And as any German mechanical engineer, I started off in the automotive industry. And here's where I got hooked on 3D printing, making mechanical parts. And 3D printing, additive manufacturing is something that's very, very powerful. So that allows me to do so I'm the kind of guy at home, whenever anything breaks, I get excited because I can spend dozens of hours reverse engineering plastic parts, printing them myself. And it drives my wife completely up the wall. But it's what it enables me to do. A guy with a limited skill set is manufacture incredibly complex parts just with the press of a button. And I got the opportunity to join Notion Systems to kind of do the same thing for electronics. And that's my goal for today, to show you how you can use additive manufacturing and the power that brings to electronics for the next step in the evolution of manufacturing. So Notion Systems as a company, we're based in Germany. It's close to Heidelberg. I'm not sure if you've ever been. You should come by in the summer. It's one of Germany's best wine regions, so it's definitely worth a visit. And Notion Systems is part of Lab 14. And this is the company I represent. So it's part of a very big foundation in Germany focused around additive and micro nano fabrication. The presentation we just saw reminded me a bit of pointer working. Nanoscribe, the company down in the bottom. They also make 3D printed parts, but on the nano scale. So as I mentioned, my goal today is to showcase how we could use 3D printing, additive manufacturing versus traditional manufacturing. But to do that, let's take a step back and look at a traditional manufacturing process chain for electronics. Here, the example for a PCB, but it's transferable to many other electronics as well. So typically, you have some kind of substrate. You need a pre-treatment for that substrate. You have to typically coat the whole substrate homogeneously with a material that can be ridiculously expensive. You have a drying process. You have some kind of exposing, for example. You have a developing where you strip away, I don't know, sometimes 99% of the material you applied in the first place. Afterwards, you have to cure, and you're done. So it's actually a process that wastes a lot of material, if I'm honest, consumes a lot of energy, and can contaminate a lot of water. So this is the drawback of the current manufacturing process for electronics. So let's look how Inkjet can change that. But to do that, first we have to look at what Inkjet is. So what you see here on the top left is a cross-section, a very basic cross-section of a piezo-based printhead. What you have here, you have a piezo element somewhere in the back of the printhead flexing and causing droplets to being pushed out. And these droplets typically have a resolution limit of somewhere around 20 micron. It's very, very fast though. So each one of these single nozzles can eject droplets with up to 100 kilohertz. It's very scalable. So one of our printheads has over 1,000 nozzles, and we can integrate a multitude of printheads into one of our systems. So the biggest system we just made prints a substrate size of 1.8 by 1.6 meters. Not sure what that is in feet. I'm not used to the conversion yet. Big substrates, and that all in a single pass. And it has over 40 printheads in it. And it's drop on demand. So we place the drop exactly where it needs to be. And something that's also very valuable is that it's multi-material. So we have bioprinters that have 30 materials in them. You can stack and combine all kinds of crazy stuff with Inkjet. So now let's go back. Same process chain. How does it look like with Inkjet? Here again, we have a pre-treatment. And this is something we have to be honest about as Inkjet manufacturers. This pre-treatment typically looks different than traditional manufacturing. Reason is that we sometimes have to control the surface energy, make the surface more hydrophilic sometimes. So we have these nice high defined droplets. After we have this pre-treatment, we do the printing, place the droplets exactly where they need to be, curing, and we're done. Same product in the end. Doing this side-by-side comparison, no material waste, much less energy consumption, no water contamination. If you're an economical operator, much reduced process steps, with that highly reduced shop floor space. So we have customers, especially in Europe, we have small shops. They don't have the space to set up traditional manufacturing, so they have to go for Inkjet just because they don't have the space. Personnel, a big issue. I also know in the US, finding qualified operators working in electronics industry is sometimes very difficult. We have one operator tending up to 12 machines, fully automated machines. and much lower capital investment.